So this is a review of angle geometry. I've put together a few different documents, so I apologise if there's a little bit of repetition. Right, so angles on a straight line. What do we know about angles that are sitting on a straight line here? Do we know anything about them? Emma?
A line equals 180 degrees.
Has been a line equals.
A line equals. Anything on a line adds up to 180 degrees.
Okay, the angles on the line add up to 180 degrees. Now, it may sound a bit heavy. You've got to be careful how you describe this. You can't say that they are 180. You have to say that they add up to, or that they sum 180. Okay?
So when you say
So I mean, if I had A, B, and C, I know that A plus C would equal 180 degrees, because the angles on the straight line add up to 180 degrees. Okay? And that's where they meet. That's where they meet on that line. Okay, so this is our straight line. We've got angles that meet there. So if there are only two of them, then there's the two angles that are up to 180 degrees. Okay. So angles and 180. Okay. Next one. So we all recall how these things are used. So often you have a diagram, and they're asking you to calculate angles. They don't want you to measure them, they're asking you to calculate them. And generally there will be a statement saying that the diagrams are not drawn to scale. So even if they look kind of good, you won't be able to get a protractor up and measure it. You actually have to calculate them. And you're calculating them, showing your calculation, but if they ask for a reason for these things, these are the things that we're looking for. So you would give a reason that the angles are on a straight line, which is why you subtracted something from 180. Do you understand the difference? Because sometimes people say, what's the reason? And they just show me their calculation for it. So the reason is that angles add up to 180 degrees because they're on a straight line. Okay? Angles at a point. So here we've got 1 point. We've got lots of different angles that meet at that point. What do we know about those angles?
All equal 360.
Careful what you're saying. They don't equal 360.
They all add up to 360.
Okay, they all add up to 360. So if I had these labeled as so, they add to 360. Okay, so that's angles at a point or in a full circle. You may think in a slightly different reason, Emily. Vertically opposite angles. So here we've got two straight lines, they're crossing each other. Sometimes they will accept just opposite. I shouldn't put that one thing. But you should have the whole wall in it. It should be vertically opposite, even if the angles are not vertical to each other. Okay, so A and B would be equal to each other. Okay, so vertically opposite angles are equal.
Could we put the other?
Yeah, it can totally be the other two. So these two would also be equal to each other. Now, also within this diagram, which other rule that we've just talked about? Well, we've got both rules actually. So we've got angles at the point, and we've also got angles on a straight line. So we've got a lot of things happening in here, because we know that these two angles here will add up to 180 because they're on a straight line. We know that altogether they add up to 360. So you've got a few different ways of answering these questions. Which brings me to another point. If you are giving a reason for something, if you've used more than one geometrical rule, you need to list all geometrical rules you've used. Okay? You could have different answers in the room for your reason, and you could both be correct as long as you're listing everything that you've given as your reason. Does that make sense? Angles in a triangle. What do we know about angles in a triangle?
180.
They
Add up.
add up to 180. Okay, so A, B, and C, so they add or sum to 180 degrees, no matter what kind of triangle they are. The angles will always add up to 180. On the right hand side, I said don't forget that isosceles triangles have equal base angles. So it could be that they told you that this triangle is an isosceles one, and they may have just told you this angle here, and asked you to calculate this top one. But you can still do it because you know that these two are equal to each other and that they add up to 180 degrees. Okay, so just be aware of that, and that the base angles are equal in the isosceles triangle. And I've just said here, remember when asked to calculate or work out the size of the angles, you must not use a protractor, and you need to learn the reason. Okay? Sometimes you're a bit harsh, and they will give you 1 mark for the total question for the angle and the reason. So if you have got the correct reason, then you get nothing. So please make sure that you're understanding the reasoning behind it, not just showing the calculation. Alright, so have a go at some of these examples using those.
Okay, so thank you students who completed this. Don't forget you've got your reasons as well as the actual angles themselves.
Alright, so parallel lines, if we've got parallel lines, what's special about parallel lines?
They're the same gradient.
More than that.
They never cross. They never cross. They're straight lines.
What was the description I gave you before? The opposite distance.
They're the same distance apart.
Nice, thank you. They are the same distance apart. Remember that they're lines that never meet. We don't like that. Parallel lines are lines which are the same distance apart. They're usually shown with arrows. So if you see anything like that, even if it doesn't really look that parallel, assume that they would be parallel. So they could be 1 arrow, they could be 2 arrows. You could have one set of parallel lines with 2 arrows and a different set of lines with 1 arrow. Okay, so that means that these 2 are parallel and then those 2 are parallel. They're not all parallel to each other. So in any diagram looking at geometry, we may see parallel lines. In these cases, we need to consider these angle reasons as well.
I remember this.
So here are 2 parallel lines. These ones here would be called alternate angles. Now this line here is called the transverse line.
It's the Z. I remember it.
Okay, so that would be a transverse line through our parallel line. Okay. So here, this is my transverse line. These angles would also be an alternate
The
to each
transverse
other.
line is the line.
So the transverse line is a line that goes through it. That's the one that. So it's the line that the angles are touching on different sides of each other. Okay. And sometimes I like to think that if you brought your parallel lines together, those 2 angles would be squished. Okay, so it would be kind of squished in a squishing machine. Shut up, that sounds stupid. I'm trying to avoid saying Z, because sometimes people get to the exam and they say they're Z angles. You won't get any marks for saying it's a Z angle. You need to make sure you're knowing that they're alternate angles. Okay? I often when they're first introduced, you may be talking about the Z shape. Okay, so obviously it's there or there. I try and remember, if you are remembering that shape of it, it's alternate. So remember A to Z is your alphabet. So that's how they may be connected. You choose a way of remembering it. Okay, but you need to remember that they're alternate angles, don't call them Z angles. And what's special about these angles?
They're equal.
They're equal, yeah. Okay, so alternate angles are equal to each other. Très bien. Corresponding. Okay, so corresponding angles. Again, it's based with the parallel lines and the transverse line. So there's my parallel lines, there's my transverse. These angles here are corresponding to each other. You can see that they are on the same side of the transverse line as each other. and both hanging down from the parallel lines. Now, equally, I could have these two angles are corresponding. I could have these two angles are corresponding, or I could have these two angles are corresponding. Okay?
Can you draw a line, please? Because there's a line on ours.
There's a line on mine too.
What? Do you guys see a line?
Yeah.
And then you need
I'm
glasses.
glasses.
It's to be fair, it is faint. It is faint.
It's not like a
All right. So as you hopefully can see, so you've got your parallel lines, you've got a transverse line. So corresponding ones, they correspond to each other. Okay. So they're on the same side of the transverse line as each other, and then they're either both below or both above the parallel lines. Okay. So that's how you can work out whether they are corresponding. So same side of the transverse line and either both above or both below. Okay? And what do we know about corresponding angles? Once we've established which ones are corresponding, they are equal. Yeah. Easy peasy, yeah? Co-interior angles. Co-interior angles. Yeah, equal to 180. Nice. So, ladies, so these two here are co-interior angles, and these are not equal. These add to 180 degrees. Now, how do we know if things are co-interior? Well, they're on the same side of the transverse line to each other, but they are surrounded by those parallel lines. Okay, so they're not both above or both below. One's below and one's above. Okay, so in between the parallel lines. Trust me, yes, no. So those two would also be co-interior, and they also add up to 180 degrees. Between the parallel lines, yeah. Okay, we're happy with that? Could you explain?
So for n, we had to show that one of the angles was 56, even though it wasn't part of the angle we were trying to find. But so you should show it on the diagram, but you must also give the reason for that part, that calculation as well. So we would show either corresponding or whatever angle reason you use, and then you can finish off with the vertically opposite and alternate. Emma?
For M, why couldn't the angle B be co-interior with?
It could totally be co-interior, which is why you.
So the other could be 143.
Yeah. So yeah. Oh, huh?
147. 147.
Sorry, hang on. So I don't have it in front of me, Emma. Sorry. Can you check? Which one? Tell me.
So M for B.
Yeah.
Would be co-interior with 37 degrees.
Yes, totally. You can use a different
Some
reason.
people didn't. They put that as they put B as 143 and A as 37.
It still will give you the same answer, darling.
But couldn't you
Because
put
remember,
37 for B?
co-interior angles add up to 180.
Wait, I know, but so B couldn't be 37.
No.
But Baker's at 90.
Co-interior angles add up to 180.
Oh.
All right. So, shh. Girls, please. So as I said, there could be different reasons that you give, and they could, Emma. They could all legitimately be correct, but please be aware that you must give those reasons.